When we look at this problem, we know the rate equation. Rate is equal to K times the concentration of HI squared. So the total exponent on this side is an exponent of 2. So that means that the rate divided by the concentration squared is equal to K. So we plug in our rate. It has units of moles per liter second. We divide by the concentration squared, and we get a K value of 0.080 liters per mole second. Now this one says, what is the value for the units for the K? Well, this is an important thing, and this will be really helpful on the next page when we introduce the concept of rate. The units for the K value will always have seconds on the bottom, and it will be liters per mole raised to some exponential power that is 1 less than the sum of the exponents. So here the exponent was 2, so I have liters to the first per mole to the first. And this is something that will help us figure out what the order of reaction is. So when we talk about the order of reaction, we can define it for each reactant, and we can also define it for the overall reaction. For the overall order of the reaction, it is the sum of the exponents for all the reactants. For an individual reactant, the order is the exponent that that individual reactant has in the rate law. So let's look at this one. We have the bromate ion reacting with sulfite to make bromide and sulfate. And we are given information about this particular equation, and this is its rate law that was provided to us after doing experiments to figure out what the exponents are. So rate is equal to K times bromate to the first power times sulfite to the first. So what is the order of reaction for the bromide ion or bromate ion? Well, the exponent here is 1, so it is first order in bromate. The exponent for the sulfite is 1, so it is first order for the sulfite. And the overall order of reaction, 1 plus 1, is equal to 2. So I think that's pretty straightforward how to find the order of reaction once you know what the rate law is. Now, here's what I was mentioning about the K value. The K for this will be liters per mole second. The order is 2, and the exponents here are 1. So the exponents in the liters per mole is always 1 less than the order of reaction. There will be times in this chapter when you'll be given some information and you'll be given a K value. It'll be your job to look at that K value and say, okay, here's the units. That means this has to be a second order reaction. And if it's a second order reaction, I use the second order equation. We're going to introduce equations for each order at the little bit later in this chapter. So that sometimes is your only clue of what you're supposed to do. So you have to be able to recognize that when you're reading the problem. Now, how do we find these exponents? It has to be experimentally determined. So we have some generic equation, A plus B reacts to give C, and we know that rate is some constant K times A to the X and B to the Y power. How do we figure out what X and Y are? We do a series of experiments using different concentrations, and we measure the reaction rate in each experiment. Then we compare the rates to figure out what the exponent is. So let's look at this. We did a whole bunch of experiments. We have the concentration of A and the concentration of B. So we started out with 0.1 molar of each, and we got some rate. Then, in the second one, we changed A, but we didn't change B. So we look in this data, and we choose one line where we can compare these two. So you're going to choose 2 lines at a time. So I'm going to choose the first and second line because I multiplied the concentration by 2 for A. This did not change. If I look at this, any change in rate is related to the change in concentration of A because B didn't change, right? So this changed by 2. Now, the rate went from 0.2 to 0.4, so it changed by 2. So when I look at that change in concentration, and I think back to my rate law, A is to the x power, 2 to the x power is equal to 2. So the change in concentration raised to the x power gives me the change in rate. So what does x have to be? 1. X is equal to 1. So I know that in my rate law, rate is equal to K times the concentration of A to the 1 power. Now I have to figure out what it is for B. So what if I use lines 1 and 3? Will that help me determine B? No. I could use lines 1 and 3 to determine A also. Or I could use lines 2 and 3 to determine A. Personally, I wouldn't pick those because then I'm changing it by 1.5 and I can't do the math in my head, right? I go for easy. So let's look at this and say, what lines can I use where I changed B but didn't change A? So it's at the bottom end here. Here I'm holding the concentration of A constant for my last 3 experiments. So I picked these 2. I go from 0.1 to 0.2 molar, so I've changed my concentration by 2. Now if I look at my rate, this time A's concentration was constant, so any change in rate is due to the change in the concentration of B. And what is this change? Times 4. So 2 to the y power is equal to 4. So y is equal to 2. So I put in the concentration of B squared. So my rate law is rate is equal to K times A to the first, B to the second. So it's really not that hard. What gets hard is when you look at actual numbers that have exponents on them, negative exponents, and you're trying to do the math in your head, figuring out if that's -4th and this is -5th, how did it change? So that time you might find it useful to have a calculator. Okay, we're going to stop here for today. So for next week,